Hi Year 10, today we're continuing on with the topic of statistics and we're looking at scatter plots, which is exercise 903 from your textbook. So sometimes two sets of data are collected from the same population or sample that is representing two different variables. A question is often asked, are these two variables related, and if so, how strongly does the value of one variable reflect the value of another? But before investigating any such relationship, a convenient method of analysis is needed. A very useful and easily constructed tool is a scatter plot. For example, the exam results out of 50 and a class quiz out of 20 marks for a class of 20 students are shown in the table below. We can graph the test and quiz results for each student as an ordered pair to produce a scatter plot. So let's do that. So what we do is our test out of 50 is along our x-axis or our horizontal, and our quiz out of 20 is on our vertical or y-axis. So what we're going to do is we're going to plot our points. So our x, so for student 1, it has a test score out of 50 of 23 and a quiz of 8. So we're going to go across to 23 and up to 8, and we're going to put a dot there. Then our next student has test score out of 50 of 20 and a quiz score of 10. So I'll put a dot there. Then we have 17, 11. And then we have 25, 11. Then we have 30, 12. Then we have 28, 13. 28, 13, then we have 35, 13, and we have 26, 13. We then have 30, 14. Oh, I zoomed in then. We then have 31, 14. And then we have 36, 15. 15, and then we have 29, 15. We have 33, 16. We have 36, 16. We have 38, 17. We have 42, 18. We have 40, 18. We then have 48, 19. We have 46, 19. And a lucky last, we have 43, 20. Like so. So that is our data plotted on a scatter plot. We can describe the relationship between the two variables by looking for a clear pattern. We can describe the relationship between the variables as form, direction, and strength. So our form is either linear or there's no relationship, positive or negative direction, and then our strength is strong, moderate, or weak. So if we go back to our scatter plot here, it is in a positive direction. It is linear as we can draw a straight line going through it. And then it is strong because all the data is close together. Let's have a look at some examples of this. So we're going to state whether the variables show a linear relationship or not, and if so, it is if it's a positive or negative relationship. So this one is not a linear relationship. This one here is totally random, so there is no relationship with this first graph. This second graph has a linear relationship as it is in the form of a straight line, so it's a linear relationship. And when we are working out whether it's going in a positive or a negative direction, we think about our gradient. So this one is going in a negative direction, so negative meaning going down from left to right. So it's negative. And our last one here, it is a linear relationship as we can draw a straight line. However, it is neither negative or positive. So it has a linear relationship, but there is no relationship linking the variables. So although we can draw a straight line, it is going to be no relationship linking the actual variables. Okay, let's look at an example. So we have this table shows the number of a product sold as its price is increased. So we're going to plot the data on the scatter plot. So the first point is going to be 10.25. Then it will be 11.24. Then it will be 12.20. Then it's 13.19. Then it's 14.16. Then we have 15.13. Then we have 13's over here actually. Then we have 16.12. Then we have 17.12. We have 18.10. So does a pattern exist? So there is a pattern, and what the scatter plot shows is that the price increased as the sales decreased. So the price increased as the sales decreased. And this is because, as you can see, so the numbers sold, so first we sold 25 and the price is 10, and then the number that we sell decreases, so the price goes up. Describe the relationship between the variables. So this is a negative relationship because it's going down from left to right. So it's a negative, strong linear, because it's lying close to a straight line. So it would be negative, strong, linear relationship. You can also write any of those words in any order there as well. Example 2, we have the table shows the average monthly temperature and rainfall for the town of Wild. So we want to plot this data on a scatter plot with the axes that are shown applicable for the data shown. So we have our first temperature of 25.8 and it has a rainfall of 103. So 25.8, rainfall of 103. Then we have 25.7 and a rainfall of 117. Then we have 24.7 and a rainfall of 131. Then we have 22.4 and a rainfall of 127. Then we have a temperature of 19.3 and a rainfall of 123, roughly there. So with the scatter plot, it is just roughly. So then we have 16.9 and 128, roughly there. We then have 16.2 and 98. So 16.2, 98. We then have 17.7 and 82. So 17.7, 82. We then have 19.9 and 69. We then have 22 and 77. We then have 23.6. 23.6 and 83, and finally we have 25.1 and 78. So what we then have is to determine the nature of any relationship between these variables. So it's very random, so there is no increasing or decreasing pattern here, and according to the set of data there is no relationship between the variables. As there's no linear relationship, we can't draw a straight line. So of the temp and rainfall in wild. Okay, so then we have this thing called interpolation and extrapolation. So interpolation is the process of estimating data that lies within the domain of the values given. This is valid when a definite relationship exists between the two variables. Extrapolation is the process of predicting data beyond given values that are given to us. This is often not useful and can lead to false results, as there is no guarantee that an observed pattern will continue beyond the data presented. So our last example is that Sam's mother measured his height every year on his birthday. His height for the even number of years is shown in the table. Show this by variate data on a scatter plot. Okay, so we're going back to our scatter plot. So our first one is 4 and it's 103. So 4, 103 is roughly there. Then we have 6 and 114, which is roughly there. We have 8 and 129. Oops, 6 is actually there. My bad. And then we have, 8 and 129, which is roughly there. We have 10 and 140. We have 12 and 152. We have 14 and 169. Oops. And 169. And we have 16 and 178. Can we estimate Sam's height when he was 11 years of age? So when Sam was 11, that is here. So roughly, he would have a height of roughly 145, or like roughly. So we can approximate. So yes, roughly 145 centimeters. The reason why we can estimate Sam's height at 11 years of age is it's because it's interpolation. So the data is within the variables or the data that we're trying to find is within the variables we have been given. Can we work out Sam's height when he was born? So we can't actually work out Sam's height when he was born. So it is unreasonable, and it shows the danger of assuming all patterns, because if we would to work out his height at birth, it would have been at about, so if we were to draw a straight line through this, for example, and continue the straight line on, his height would be 178 degrees at birth. Oh, sorry, it would be just 78 degrees at birth. And at 25 years of age, we don't have enough data to go along. So the answer is no, because of extrapolation. Because the data that we're trying to find is outside of our data set. And our answer for part II is the same as well. So we can't actually estimate his height because of our extra. Lastly, the range, mode and median can be determined for each of the variables from a scatter plot by observation and counting. So for this scatter plot, there are 15 data points, so the median would be represented by the 8th data point. So what we do is we can find the median for the height and the median for the number of children in the family. So the lowest height here, if we're just talking about height, so our lowest height is 153 and our greatest height is 180. So we can work out our range by going 180 minus 153 to get 27 centimeters. Our median is our 8th score, so we count across till we get to our 8th score, which is 166. Our mode is our most frequent score, so it's our score that occurs the most, and so 160 occurs twice, hence why it's the mode. We can then do the same for the number of children in the family. So the lowest number of children in the family is 1 and the highest number is 6. So we can work out our range to be 6 minus 1, which equals 5. Our median score is 8, so we cross out our scores going along, which is this one here, which is a median of 3, and our mode is what occurs the most. So we have the most scores occurring at 3.